A system of equations is one or more equations. Actually, they can also be inequalities as well. But the solution to a system is an ordered pair. So you want to write an x and a y. So it's going to be an x and a y such that it satisfies each equation or inequality. So first question, is 2, 3 a solution to the system? So in order for it to be a solution, it has to satisfy both of these equations. So I'm going to let x be 2 and y be 3, and I'm going to see if when I substitute them in, so 2 times 2 minus 3, does that equal 1? So I substituted 2 in for x and 3 in for y, and I'm seeing if the left-hand side equals the right-hand side. So in this case, 4 minus 3 is 1, so it works. Then I try the second equation. Does 2 plus 3 equal negative 5? No, it doesn't work. So no, 2, 3 is not a solution. So it has to satisfy both equations. Okay, so they both have to work. SOLN is a shorthand word for solution. Okay, number 2, solve by graphing. So the graphing will be the intersection of the two lines. So the first one I'm going to solve for y. Okay, I'm going to put it in slope-intercept form. So it's going to be y equals 5 minus 2x. Or this is the same thing as y equals negative 2x plus 5. So I'm going to graph, start at 5. And I got to erase this because I'm going to go down to right 1, down to right 1, down to right 1. Okay, so I have this right here. And my second equation is going to be solve for y, put it in slope-intercept form. So it's going to be 2 plus x. So I'm going to start at 2 and go up 1, right 1, up 1, right 1. And so I can see that the intersection is going to be 1, 3. So x is going to be 1, y is going to be 3. So I'm going to substitute it in to the first one. 2 times y plus 3. Does that equal 5? So I'm looking at this first equation. So when I plug in 1, 3, yes, it works because 2 plus 3 is 5. Now I'm going to plug in 1, 3 into the second equation. Negative 1 plus 3, that equal 2? Yes, it checks. So I checked my solution and 1, 3 is the solution. So to solve by graphing, you want to see where they intersect. So this next one is going to be y equals 2 minus x. So I'm going to start at 2 and go down 1, right 1. And then the second line is going to be y equals 6 minus x. So start 6, go down 1, right 1. So in this case, there's no intersection point. Now the reason that they're not intersecting is because these lines have the same slope. So this would be no solution. These lines are parallel. So no solution. The second line, or second equation, I'm going to solve for y. So I'm going to have 2y equals x plus 8, because I added 8 to both sides. Then divide both sides by 2. So it's going to be y equals 1/2 x plus 4. So I'm going to graph this line, start at 4, go up 1, right 2, and connect. And then I'm going to graph the second line, which if I start at 4 and go up 1, right 2, it's the same line. So if the lines are exactly the same, there's an infinite number of points of intersection. So the solution's infinite. Now, this is different than putting all real, I started spelling that wrong. This is different than writing all real solutions because they're all real numbers. Because not this ordered pair is not a solution, this ordered pair is not a solution, just the ordered pairs that are on these lines, and there's an infinite number of ordered pairs on this line, so that's why it's infinite. Another way you can solve a system of equations is by substitution. Graphing is not always the best method because it can take a long time and you need to have graph paper. So to solve by substitution, what you want to do is solve for one of the variables. So I tend to find a variable that does not have a coefficient that is not a number 1. So I'm going to solve for x right here, or y, because they both have a coefficients of 1. So I'm going to solve for x. So x is negative 12 minus y. So then I take this x is negative 12 minus y, and I substitute it in for x into the first equation. So it's going to be 2 times the quantity negative 12 minus y, then minus 3y equals 6. So now I have an equation that's only y. So it's going to be negative 24 minus 2y minus 3y equals 6. So negative 24 minus 5y equals 6. Add 24. So negative 5y equals 30. So y equals negative 6. So once you get one of your equations, y equals negative 6, you're going to plug it back into either one of these and solve for x. So I would choose to solve for x in this one. So this is going to be x plus negative 6 equals negative 12. So adding 6 to each side gives me x is negative 6. So at the end you want to write your answer as an ordered pair, the x and the y. Or if they're not x and y, write alphabetically what the ordered pairs are. Second example, I think the easiest variable to solve for would be this y. So I'm actually just going to add y to the other side, because this is 0 over here, so I'll have y equals 3x. Now I'm going to take 3x and substitute it in for y right here. So I'm going to have 4x plus 3, instead of writing y, I'm going to put 3x in parentheses, equals 26. So now I have 4x plus 9x equals 26. So 13x equals 26, x equals 2. So once I have x equals 2, you can plug it back into either one of these. I'm going to plug it into this one. I think that would be easier again. So it's going to be 3 times 2 minus y equals 0. 6 equals y. So my ordered pair is going to be 2, 6. Alright, you can buy CDs at a local store for $15.49. You can buy each. So a lot of times when I see each, this means I'm going to multiply these two numbers. You can buy them at an online store for $13.99 each, plus, that'd be a plus sign, $6 for shipping. So when you're buying shipping for $6, that doesn't matter how many CDs that you buy. No matter what, the set cost is going to be $6 for shipping. Find the number of CDs. So whenever I'm asked to find something, that's going to be my variable. So number of CDs is going to be X that you can buy for the same amount at the two stores. So I'm going to write equation for cost of each store. So one is an online store or a local store. Local store is $15.49 each, so $15.49x. The other store is $13.99 each plus $6 in shipping. So I'm going to set 15.49x equals 13.99x plus 6 and solve for x. So when I solve for x, I'm going to subtract from each side here. So I get 1.5x equals 6, because I subtracted $13.99 from each side. So 6 divided by 1.5 is 4. So 4 CDs. It's going to be the same. All right, fill in the table for what each solution looks like graphically and algebraically. So if you have infinite solutions, graphically, you're going to have line 1 and line 2 be the same line. Algebraically, when you're solving, you're going to get something that's true. So you're solving, and your variables knock out and you end up getting 0 equals 0 or 6 equals 6. Something that when you're solving a linear equation you would write all real numbers. Well, in a system it's going to be an infinite number of solutions. No solution for a system is two equations of lines, or it could be a curve later on that do not intersect. So if they don't intersect, when you're solving algebraically, the equation would be false, and you'd have something that was not true. You'd have something like 6 equals 4 or 3 equals 7. So those are the differences algebraically and graphically for no solution and infinite solution.